number 3 says this. Consider this function. Okay, this is like the original function. And I want you to first of all find the reciprocal. Well, that's pretty straightforward. What will the reciprocal function be? Y equals to? Yeah, 1 over x squared minus x minus 6. Okay, that's it. So now, after this, don't graph yet, but I'm saying state the non-permissible values of x, and then find the equations of the vertical asymptotes. Okay, so remember, the NPVs come from where? You look at the denominator, and then you can't have the denominator equal to 0. So what you're really saying to me is x squared minus x minus 6 cannot be equal to 0. How do we solve for x? Factor. Two numbers that multiply to -6 add to -1. What would that be? Yeah, -3 plus 2. Okay? And therefore, when you solve, you get x. Now, in this case, it's not equal to 0, so x cannot equal to 3. X cannot equal to -2. These are your non-permissible values. Okay? Now, how do these relate to your vertical asymptotes? Well, aren't these the same values for your vertical asymptotes? Yeah, but when we talk about vertical asymptotes, we say x equals to 3 and x equals to -2. These are my vertical asymptotes. Okay, so they're really connected. You're doing the same thing, but when you describe the answer, be careful. If I asked you for NPVs, you have to say not equals to the number. If I asked you for the vertical asymptotes, I say give me x equals to that particular number. Okay. Now, the next part here is find the vertex of the original function. How can you find the vertex of anything? Review now. Vertex. How do you find the vertex of a quadratic? Without the calculator. Completing the square. Woohoo! All right. So let's complete the square. So let's do that. Our original function, f of x equals to x squared minus x. Now I'm going to leave some space. Do you remember how to do this? Take half of the coefficient in front of the x term. So that's -1 divided by 2. That's -1/2. We're going to square it. What's -1/2 all squared? +1/4. I'm going to add in +1/4 to balance it out. I'm going to also -1/4. And then I'm going to write this as a squared term. That would be x minus 1/2 all squared. 6 1/4. 6 times 4 is 24. How about -25/4? And if you have it now in vertex form, what? What? Right, so -6 is the same thing as -24/4. Agreed? -24 minus 1 is -25. Okay? So now, what's the vertex going to be then? What's the vertex? Oh, come on, review, dear friends. Hello. I'm going so fast. Remember, it's the opposite. So it's +1/2, but the actual y value stays the same, so that's negative. Good. Okay? By the way, there is another way you could have found out the vertex. Did you want to know?
Yes. Is it easier?
Possibly.
Okay. Yes.
Calm down, Gravillo. Okay? Now, if you don't like completing a square, you can use, listen up please, you can use the zeros to help you out. Do you know how? Okay, listen first. Okay, listen and I'll show you. Listen first. Remember a beautiful thing about a parabola? It's so beautiful because it's symmetric about... Anyways, don't listen. Oh man. Anyways, it's nice. Okay, it's nice because it's symmetric. Now notice what I'm saying here. Don't graph this out. Just watch. Okay. From above, you said that your zeros are at 3. Oh, sorry. At 3 and negative 2. Where do you think the zeros are going to be if this is symmetrical? The zeros are there. Sorry, where's the vertex going to be? In the middle, right? What's the middle between negative 2 and 3? Hello? What's the middle of negative 2? What's the average of negative 2 and 3? Negative 2 plus 3 is 1. 1 divided by 2 is 0.5. Hey, look at that. The x value is 0.5. So notice if you were to, and you can write this down now, just average the zeros to find the x value of the vertex. Negative 2 plus 3 divided by 2, negative 1. Okay, so you're like, well, that's great, Mr. Lee. It's not negative 1, it's negative 1/2. Okay, that's great. But wait a minute, the vertex has an x-coordinate and a y-coordinate. How can you find the y-coordinate now? That's right. Just go ahead now and plug it into the original question, right? Plug it into f of x. So I'll say now f of negative 1/2 is equal to negative 1/2. Let me write this down first. Squared. Take away negative 1/2 minus 6. What's your question? Aileen first and then Hisham. Yep. How come it's negative 1/2? Right. I'm an idiot. That's why. Just making sure you're listening. It's 1/2, not negative 1/2. Hisham, was that what you were going to say? Yeah, thank you. This is why teachers should look up and answer questions first before thinking they're doing everything right. Sorry about that, dear friends. My dear friends. Well, the friends help me. The other ones who don't tell me anything, you're just like, heh, 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 let them make mistakes. Okay? All right. So once again, dear friends, it's the same thing. Now, remember, this is all just find the vertex. My question was find the vertex, and then how does knowing the vertex help you graph out the function of its reciprocal? Well, what do we know about one of the points on the graph then? So I'll say if the original, okay, and please write this down, if the original point is a half negative 25 over 4, I'll say that the reciprocal point will be what? Okay, now careful. You don't reciprocal the x value. It's just the y value, right? So the x value stays the same, but your y value now becomes negative 4 over 25. Okay? Please write that down, because that's what I'm asking you to do here. Why did I reciprocal it? Because I'm asking you. We're doing the reciprocal. I said, once you know the vertex of the original function, how does that point, which is the one in green here, help you graph out the function of its reciprocal? So what that means is that this point I will transform into negative 4 over 25. Okay? Now, one last thing here. Does the graph have a horizontal asymptote? Yes. How do you know? Remember how to find the horizontal asymptote? The limit as x approach to infinity of 1 over x squared minus x minus 6. And to do this, and I showed you this earlier in the extra stuff, and by the way, those of you doing calculus next year, you'll see this again. What I'm going to suggest to you is, can you please factor out the highest power of x? Well, what's the highest power of x in the numerator? There is no x, so let's leave it as 1. What's the highest power of x in the denominator? X squared. Okay, now this gets kind of messy. Listen and watch carefully. X squared divided by x squared leaves us with 1. Okay, now take the negative x, we're dividing it by x squared to factor it out, so you get negative 1 over x. Okay. So I took the second term here, negative x divided by x squared. How about the last term? Negative 6 divided by x squared. That's just minus 6 over x squared. Now you're thinking, why, Mr. Lee? Why? Exactly. So let me tell you why. Over here, there was a property that I told you. If I take the limit, and please write this down, as x approaches to infinity of any particular function of x with a power, okay, with any type of regular power, 1, 2, 3, 4, 5, what does it become? It's like having a really big number taken to some power, really big squared, really big cubed, really big power 4. What does it have? What happens to it when I go 1 over? Really small, like 0. So what I'm showing you here then is that this becomes 0. This becomes 0. So what you have left over is the limit as x approaches to infinity of 1 over x squared times, and I guess it's just 1. Well, now if you look, you have 1 over x squared. When I plug in infinity now, what do we get? Infinity squared is still infinity. 1 divided by infinity is 0. So therefore, your horizontal asymptote is equal to y equals to 0. Okay? When isn't there a horizontal asymptote? When you calculate this limit and the answer is infinity. If it's anything else besides infinity, like a number, like 0 or 1 or half or 10, that's an asymptote. If it keeps going, it'll be infinity. It's horizontal, yeah. Okay, ladies and gentlemen, last thing for you to do. Sketch both the function and its reciprocal now. So all this information will help you out. Let's go ahead and sketch this out. Let's do this together since you guys are running out of gas. I know. Okay, let's take a look. Okay, let's focus for a few more seconds or minutes, and I'll be very happy. Okay, here we go. Let's graph this out. Y equals to x squared minus x minus 6. Let's do that first, okay? Where are my x-intercepts? I told you, 3, negative 2. Where's my vertex? Yeah, 1/2 and what? Negative 25 over 4. Uh-oh. This is bad, so let me do something here. Let's change our scale. Let's make this negative 2, negative 4, negative 6, negative 8. This is 2. This is 4. This is 6. This is 8. That just helps me out. Because my vertex is 1/2, comma, negative 6 1/4. So right about down here. So here's my parabola. Okay. Now, how is this information that we did earlier going to help me out now? Well, we know what the vertical asymptotes are, do we not? Yes, sir. Good. I like that. Plot them there. Okay. Now, I know we can do that big, small stuff, but before we do that, let's do the invariant points, where the y value equals to 1, big dots. So where are my big dots? Right here. Right here. Where are my other big dots? At what value of y? Yeah. Y equals to 1, yes. Oh! Yes, thank you. I wrote down as y equals 2, my fault. Over here. That's right, I changed my scale. Good call. Thanks, friend. Do you know why I confused you? Look, I made this scale now 2 units, right? So I originally put on this line, that's not 1, that's 2. So 1 should be somewhere in the middle here. My bad. Okay, how about negative 1? Let's do that too. Right about here. Right about here. Okay, so those are invariant points. That's great. Now let's use this vertex, and let's use the vertex to help us out. We know the vertex of the original graph was 1/2 negative 25 over 4. What's the vertex of my new graph going to be? My reciprocal graph. 1/2 negative 4 over 25. So put a dot around here and just write the coordinates 0, oh, sorry, that's not 0. 1/2, comma, negative 4 over 25. Okay? Now, you do the rest. You already know what it looks like, so don't worry about making it exact, but just sketch it out. So I'd say the bottom part looks like this. Okay? And then the top part here, small become big, big becomes small, big, small, small, big. There you go, dear friends. There's your graph. Okay? So I'm going to ask you to try to finish off example number 4 on your own on the back, okay, because it's just a question from the textbook. I also am going to ask you to work on the questions underneath, and whatever homework you haven't done for chapter 7, may I strongly suggest you work on that this Easter break, because your chapter 7 test will be Friday.